my name is Darian Richmond, and right now I'll be showing you how to use implicit differentiation to solve the equation tangent of xy equals xy. This is problem 3.7.10 in the book. Alright, so the first thing we do is find the derivative of all this. In the derivative, well, we're going to be solving for dy dx. So the first thing we do is find the derivative of all this, which is secant squared of xy. And since we're solving for dy dx, we'll need to differentiate with respect to x. So we end up with this times the derivative of the base, which is going to take product rule. It will be x times dy over dx. That's because it's the derivative of y with respect to x, plus y times dx over dx. And that's because we took the first one, which was y, multiplied it by the other one, the derivative of the other one, which was dx over dx, which later that will simplify to be 1. That equals x dy over dx plus dx over dx. Alright, the next step is that we can simplify all these, take out the dx over dx's, which will give us secant squared of xy times x dy over dx plus y dx over dx simplifies to be 1 equals x dy over dx plus 1 times y. I apologize, I forgot about this y up here. Alright, so now down here we'll multiply all this out and it will give us x dy over dx times secant squared of xy plus those two, y secant squared of xy equals, this side stays the same, x dy over dx plus y. Alright. Now we want all of the dy's, because that's what we're solving for, to be on one side. So we'll subtract this x dy over dx from both sides, and we'll subtract this right here and addition sign. We'll subtract y secant squared of xy from both sides, and that will give us x dy over dx times secant squared of xy minus x dy over dx equals y minus y secant squared of xy. Alright? Now we can factor out a dy dx, because both of these terms have dy dx in them. That will give us dy over dx times x times secant squared of xy minus x equals y minus y secant squared of xy. Okay. So now, since we're solving for dy dx and we have all of this nice and compartmentalized, we can divide by this on both sides. And it will give us dy over dx equals y minus y secant squared of xy over x secant squared of xy. Alright, now I'm not entirely sure if you're going to be able to see this very well, so I'm going to increase the size of my font. Okay, so you can leave it like this. You've solved for dy dx. However, you can simplify this further. by taking out a y on the top and an x down here. I apologize once again. This was supposed to be x secant squared of xy minus x. It's this right here. Okay, this term. That whole, okay. So if you factor out a y up here, you end up with y 1 minus secant squared of xy over x times secant squared of xy minus 1. Alright, now these two are almost the same, except their signs are swapped. So if you factor out a negative 1, I don't care if you do it from the top or the bottom, I am going to do it from the top. You'll end up with negative y secant squared of xy minus 1. I just swapped those two signs because I factored out a negative 1 over x secant squared of xy minus 1. Now these two are the same. You can cancel them out, and you will end up with dy over dx equals negative y over x. And that is how you solve for dy dx using implicit differentiation in terms of x and y. Thank you.